The meaning of this session title, Tissue Reactions, the road of the road from science to protection, is very important for clarifying the cancer and the non-cancer risk assessment. In this context, I would like to explain our thought by focusing on the three critical points: epidemiological data, analysis, detriment, mechanism for damage. Needless to say, ICRP publications and recommendations greatly impact radiological protection systems worldwide. Publications, recommendations by the ICRP also influence society directly or through the IAEA. The ICRP publications listed here have generated much discussion on the controversial issue of non-cancer effect at low doses. In the draft report, tissue reactions and non-cancer effect were analyzed using new information and new approaches. In the statement on tissue reactions, the Commission recommended lowering the threshold dose for the lens of the eyes to 0.5 gray and made the radiological protection community aware that threshold doses for circulatory disease may also be as low as 0.5 gray. This is a clear illustration of the fact that when the ICRP publishes reports, radiological systems are impacted soon thereafter. To this end, publications, recommendations by the ICRP should be easily understood, able to be implemented, and have a firm scientific basis. For these reasons, we feel it is important to develop a radiological protection system based on scientific information and to develop consistency in the treatment of detriment for low dose cancer and non-cancer effect. ICRP Publication 118. Publication 118 was completed 1 year following the publication of the draft report and statement on tissue reactions. Publication 118 contains much important information. One of the biggest differences between publication 118 and prior ICRP publications regarding threshold reactions was the treatment of cardiovascular diseases. Publication 118 estimated thresholds for circulatory disease effect using three important concepts. Epidemiological analysis was used to determine the shape of the curve. This in turn was used to estimate excess relative risk for circulatory disease. Mechanism for damage. Regarding detriment, threshold doses in publication 118 are defined as the dose estimated to result in 1% disease incident above background. Firstly, epidemiological analysis. Cancer risks were found by estimating excess relative risks from atomic bomb survivor data. Similarly, publication 118 concluded the shape of the dose response curve for circulatory disease was linear, used this to estimate ERR based on epidemiological data. The epidemiological basis for risks of non-cancer effect should be verified. More importantly, the shape of the dose response curve for non-cancer effect should be confirmed. The question of linearity of non-cancer effect at low doses is a critical point and will serve as a starting point for discussions regarding non-cancer risks. Epidemiological analysis developing discussion. Several papers published following publication 118 indicate a potentially non-linear dose-response relationship for circulatory disease. Science and Value workshop was held last year in Tokyo. In this workshop, Dr. Suzuki, who is a former RER scientist, indicated that a subtype of heart disease displayed significant heterogeneity and in some cases did not display linear dose response. He also addressed the importance of AHS data when examining accident data, examining incident data. Dr. Ozasa from REF also suggested that subtypes of heart disease did not display linearity. This presentation covered both LSS lifespan study and AHS adult health study and demonstrated that a linear dose response for cardiovascular disease, CVD, may be an artifact of a combination of heterogeneity of disease, subtypes, and analysis period. These presentations also indicate that a non-linear dose response with a possible threshold may be a more accurate model for cardiovascular disease. In addition to these two presentations by Dr. Suzuki and Dr. Ozasa, other reports also explore the issue of linearity. Epidemiological data analysis is important for finding excess risks for non-cancer effects. These publications suggest possible non-linear dose-response relationships and indicate that the dose-response curve may need further analysis before recommending threshold doses for circulatory disease basis. Disease. Summary of epidemiological analysis. Recent epidemiological analysis of LSS data indicate the shape of the dose response for some disease subtypes may not be linear. In addition, AHS data has not shown a clear association with linearity in the low dose region. In this context, in-depth discussion is necessary for clarifying the shape of the dose-response curve for non-cancer effect, especially for circulatory disease. Secondary determinant. Cancer risk estimates are based entirely on LSS data and are modeled stochastically. The primary component of cancer determinant are probability of attributable fatal cancer, weighted probability of attributable non-fatal cancer, and length of life loss if harm occurs. Determinant adjustments are made for individual organs of interest. Determinant adjusted risks are summed to determine overall risks. Stochastic effect and tissue reactions were originally distinguished as different types of biological reactions. For this reason, severity should be well defined for both types of data. Summary of determinant. There is a need for quantifiable metric to account for severity. This could take the form of determinant similar to that used to adjust nominal cancer risk. The use of ERR to estimate non-cancer risks is conducive to the use of the determinant adjustment. The use of determinant factor would preclude the need for the use of an incidence value In any case, the appropriateness of 1% incidence value is debatable, since publication 118 find excess risks for non-cancer effect, much like excess risks are determined for cancer. It may be possible to define a metric to account for detriment that could be applied to both types of effect and used to harmonize risk determinations for cancer and non-cancer. And mechanisms. The understanding of the mechanism for damage behind non-cancer effect will also contribute to the proper interpretation of dose response. Publication 118 indicates that mechanisms for damage may differ at low versus high doses. Assumptions regarding dose response were made primarily on epidemiological data at high doses, dose rate. If mechanisms for damage are different for low dose versus high doses, this could influence the accuracy of the chosen dose response models in low dose region. Conclusion. As we have learned following the accident at Fukushima, the activities of ICRP are crucial to modern society. For this reason, we are hopeful that many fruitful discussions will take place during this session and this symposium. We hope the result of this symposium will be reflected in future development of the radiological protection system through the discussion in ICRP. Thank you for your attention.